First one, practical thing. If you have a question, don't wait till the end of the session because you might forget. So if you have a question, just ask the question. Raise your hand or whatever, throw a shoe, I don't care. Just throw my attention and you can ask your question. The next 50 minutes I will be talking about automatic generation of test data using machine learning. Now, just to get an idea of what is the overall knowledge in this room or experience with synthetic test data, let's do a raise of hands. So if you already have some experience with synthetic data, manually or with tools, that's not important, but the use of synthetic test data, if you have some experience with that, if you can all just raise your hand. Yeah, it's quite some people, so that's probably also why you're here. Now, to make it a bit more practical of what we're talking about from the start, on the screen here, you see two subscreens. And each of them, so I've numbered them 1 and 2, and each of them has payment information. So the typical information, payment from this person to this person, the amount, and so on. And they can either be real data that I'm showing, or synthetic data that was generated with a machine learning algorithm. So let's call that fake. So the question will be whether they are fake or real. And I will do a raise of hands also. So let's first go for the number 1. Whoever thinks that that is fake information that you're looking at, that was generated by an algorithm, and I hope that you can see it a bit. Raise your hand if you think that that is a fake one. Not that many people. Same thing for the number 2. If you think that the number 2 is a fake one, about the same amount of people. I think I've seen some doubles. Who thinks that they're actually both fake? They're both fake. Actually, you can see it because the yellow part is the identification of the payment in the system. And so the first time that we created these synthetic payments, it's automated, so we can do a lot of them. So we did like, let's do 10,000. So we injected them in the test environment, but that was an acceptance environment where users were testing. So yeah, they start complaining like, oh, what are you doing? So what we did, we added the word test in the identification, so we can make the distinction between what is the real payment data and what is the synthetic one or the fake one. Because yeah, it can get pretty difficult to make that distinction. So that gives you some idea, and I will talk more in detail about this project. It was a SEPA payments project that we did. So I will talk more about it, but it gives you an idea of what we're actually doing. Now, for me, this started 3 years ago. Actually, I had a project, and for that project, I had the data scientist was assigned to my team, but the project was cancelled. So yeah, instead of letting the data scientist go, in my team we had a lot of experience with testing, and I also come from a testing background. We said, okay, let's make a list of things. What can we possibly do that is linked to testing and for which we need a data scientist? So we made our little list, and on the first item on the list was to use artificial intelligence to generate test cases. That was the first thing we had in mind to look into. We researched that a bit. That's 3 years ago. So, and at that time, that was a very tough problem. So we didn't do that. With the evolution of language models, might be something we have to revisit. That might be changed. But 3 years ago, that was a very tough one. The next one on the list was the generation of test data. So we also researched that a bit. What is being done in the company? Are people talking about that in conferences and so on? And then we found a research paper from MIT, which talked about it, and there was an open source, and that's where we started. So my name is Wim Blommaert. I'm leading a team at ING, and since 3 years, this is what we do. We generate synthetic data. We have done 14 projects, so it's moving forward. We get more and more demand. So yeah, that is what we are doing. The lessons learned here is if you ever find yourself with a spare data scientist, little list, make little list, and you never know what follows from that. Now, why would we even bother? Why invest in tooling and methodology to automatically generate synthetic test data? Why would we even bother with that? Because after all, it's an investment, it's an emerging technology, so you have to learn these things. Now, we all know that when we deliver software, we release software to production, that things happen, and it's not always the things that we would like to happen. And that's why we do the testing. But if we do the testing, or let's say when we do the testing, because of course we should always do the testing, when we do the testing, we need test data. So the testing is only as good as the test data we do have for that testing. So the problem in the end comes down to having the right test data to do those testing. Now, getting that test data can be a bit of a problem. It can be a lot of work. For instance, you need to, perhaps you'll copy that data from a production environment, which probably means that you will have to write some masking scripts, which you will have to write, run tests to mask that data. So that's a lot of work to get that data. It can also be a privacy problem or nightmare, depending on how bad things get. For instance, in the bank, we have done projects for teams that were not allowed to copy data from production, even if they did the masking. Or for instance, if you want to put your data in Google Cloud or something, very often you just can't do it, even if you want to do the masking. And that means that privacy is working against you. So privacy might be something that either stops you from having that data, or at least it will push you to do all the masking scripts, and that can get quite complicated, because these masking scripts have to be done in a consistent way. If you have joins in your software and you mask, you have to join both ends of the join need to be masked in the same consistent way, that type of a thing. Getting the test data can be slow. Perhaps you're not the team that can copy that data from production. So you probably have to ask another team, and they might not immediately have time. That might go in their backlog, and then you have to wait. Also, when the data is copied, that might take time. It will have to be checked. You might have to run that data through a process to get it to the point where you can do the actual testing. And then the last problem you will have is that that data might be incomplete. Typically, if you copy data from production, there will be cases that do not exist in production, so you will also not have them. For instance, at the start of COVID, in Belgium, there was a kind of government collateral given to the small and medium enterprises. So they could get collateral from the government, so they still could get loans. But that was new, so if we wanted to test that and we copy data from production, those type of collateral do not exist in production because they're new. So that puts some limitation on if you're just going to copy data from production, special cases might not exist or something new might not exist. Now, with the synthetic data, we try to solve these problems to some extent. So, and I will describe how it works, and I will give 2 examples. But basically, it is an automation. So that means that once you have it set up, it can be very fast. So it can save you time. So it's fast, it's fully automated. Of course, you need to set it up. And the coverage can be very high. So the incompleteness, I will show that you can generate data that you need. So if you have test design and there are certain cases that you want to test, you can force the generative AI to generate data specifically in the, following your instructions, so to speak. So it can be much more precise than just copying millions of data from production and hoping that whatever you needed was in there. And privacy, synthetic data is very privately safe. There's still a lot of research. But in regulation, actually, they don't say much about it. They actually just say that it's not part of the regulation. So they say synthetic data is not personal data, and you can stop reading, you're not subject to regulation, and that's it. But in any case, it is much safer than masking, for instance. Because in masking, you might only mask certain private fields, like the name, the phone number, address, and so on. And in synthetic data, everything is synthetic. So not only those direct identifiers, but everything is synthetic, which means that an identity attack is actually almost impossible. Now, the good news is that we have a huge leverage in our company, because we have a few thousand engineers, software engineers, or should we call them like that? I don't know, but so we have like roughly 2,000 software engineers in the company, and all of these people in some way or another are involved in testing. So at some point they will always need test data. They might be testers, they might be the people that have to set up the test data, they might just be the developers that need to do the testing. But that means that whatever we do for the synthetic data has a big leverage. We're not just helping 20 people, potentially we have 2,000 and even more people we can help. Now, where does this come from? I mean, it didn't all of a sudden appear. These are things we have become familiar with and more the last years. This is what we call deepfakes, so that type of thing. Most people, when they see this, might still know that it's not real, but it's getting really hard. I've seen videos of Elon Musk's scam, and to be honest, first 10 seconds, I didn't really know what this was. So it's really getting very hard. So this technology already exists for, let's say, the last 10 years, where we are able to use machine learning to learn from real images, in this case of Trump, and then build models, and then we can generate our own images of Trump, and even complicated ones in certain contexts. And you will see, I will explain that actually what we are doing with the test data is actually very similar to this. So it's a bit based on this technology that has been around for, let's say, 10 years. There are some differences. You could say, yeah, but why didn't we have the test data earlier? It turns out that it's a bit harder problem. So actually, this might be counterintuitive, but doing these deep fake images is much easier than doing the tabular data. So data that sits in tables, especially if it's relational models with many tables linked with referential integrity, is a much harder problem to solve than generating these images. But in essence, it's the same type of problem. The last years, there has been already, with these images, more serious application of these solutions. For instance, in the medical sector, since quite some years now, what they do is, for instance, they have a software that can detect, so you give it an X-ray picture, and then it can give the probability of there being a certain pathology, a disease, or a tumor or something. So they have to train that algorithm with real pictures. Now, luckily, I would say, they don't always have that many real pictures. So what they then do is they make the synthetic images, so they train a model on the real ones they have. Then they can, from that, generate the fake ones or the synthetic ones, and then they mix them up. And actually what they see that in a lot of cases, the mixture of real and synthetic pictures, so what we call augmented data, actually gives a better result than if you would just be doing this on real data. So that's not new either. So in medical sector, also in automotive testing of self-driving cars and so on, the use of synthetic images for testing models is something that was already done, let's say, at least for the last 5 years. But now we can do this. So we can now do it on tabular data. So tabular data, that's the data we typically have in tables, Excel or Oracle relational tables. And here what you see is that the bottom one is real data. Of course, it's just a snapshot of one table and just a few rows. and the top one is synthetic data, which was derived from it. This is from one of our projects, which is regulatory reporting to the ECB, European Central Bank. And what you see here is that the machine learning should learn from the real data at the bottom, so it can produce the synthetic data at the top. And it should do it in a way that it respects what we would say the statistical characteristics of the data. Now, okay, that's a nice phrase, but what does that actually mean? If you look at one column, for instance, you have the column amortization type. That's a type of loan, let's say. And for instance, you have a lot of bullet. Bullet payment is a loan that gets paid at the end in one go. You don't do like monthly payments, you pay it at the end. If we have a lot of these bullet payments in the real data, then we would expect to have that also in the synthetic data. Perhaps not exactly the same number, but same or statistically the same, let's say. So that is one thing that the algorithm learns. And another thing what the algorithm also should learn is the correlation between columns. For instance, there is a column which indicates the maturity date, so the end date of the contract. And there is a column indicating the start date. Here it's called inception date. And of course, the maturity date should be bigger than the inception date. And now if somebody's checking that actually, you might see that it's actually not correct on the second line. So on the line 236, this is not correct. When we had seen that, we also asked the question, oh, why is that? The answer was that in the data we trained from, there was data quality, so it was actually in the data. So the algorithm learned the errors. But it can happen because I will explain it's a statistical process. And what we can then do, we can force the algorithm, we can put a kind of constraint. So we can say, we can force it to respect that difference.
So you made it, the AI, less like it's in production? Because apparently in production you have these errors.
Yeah.
So don't you want your test data to be as
close as possible,
as,
yeah.
as in production?
Yeah.
Because
Yeah. So the question is, yeah, I'm supposed to repeat the question, so which is good for the video. So the question is, and that's a very good question, and we had a lot of discussions on that with our customers, is if you're doing this, so in production you have the error, should you then train the error or should you remove it? What do you want? And actually the answer is we ask our customers. So the customers in a lot of cases they will say, what you indeed propose is that leave it, because production has this, so we also want it. In some cases, they want to remove it. I must say that in most of the cases, they actually just want to keep it, because in production it might also be, and yeah, if in production such cases can exist, you want to test what your algorithm does with that. So yeah, that was a very good question. But the thing is, we always must ask our customer, and in most cases, they will just say, keep it, indeed. Yes, please.
How about data that falls outside the median? Like the lower
Outliers, extreme cases,
exactly.
Yeah. I will come back to that. We can do stuff with that. Outliers is typically a problem in machine learning because they might either not be detected or, but I'll get back to it, yeah. Yeah, Gartner, as far as Gartner goes, Gartner has this vision that, yeah, like in 2030, most of the data we will use to test, this is not about software testing, it's about data science, so using data for training models, that by 2030, most of that data will be synthetic, which could or could not be true, I don't know. But for testing, it might also go that way. It might be a bit slower, but I think that gradually we will start using more and more synthetic data. Although I do believe that it will always be a mixture. For some testing, it's case by case. For some testing, it's just, yeah, at some point you want to do the real thing. But you see that the proportion of synthetic data in these processes, software testing or data analytics, is growing. We already see that. Now, The interesting question then, of course, is how does that now work? How do we do that? So what we are using software which was originally developed in labs in MIT more than 5 years ago. So that was developed in MIT, and that was an open source. And then 3 years ago, it became too big. So I think now they have like 1 million downloads. So when it becomes too big, typically they do a spin-out from the university. So they create a startup. So that startup was created 3 years ago. It's called DataCibo, and that's our partner. So we work with them, and we use their algorithms. No, that still doesn't tell you how it actually works. That just tells you what we are using. So this is how it works. It's just the same as with the Trump pictures, basically. We need to train a model of what we are trying to make synthetic data for. So we have to take real data, and that's our training set. So top right, training set, real data, and we give that to our algorithms. That real data can either come from production, which is okay because our software runs in production. So it is allowed to consume the data at that point. But it can also be data from a training from a lower environment, from a test environment or an acceptance environment. That is also possible. It just has to be data that is representative of the data that we want to create. And that depends, because if you use data from a test environment, perhaps there has been very aggressive masking on that data, and then perhaps you can't use it. But in most cases, we'll just use production data. We give that data to our software. That software is a Python, written in Python. It's a software development kit. So we use these algorithms, and we build all kinds of Python code around it. And what that software will then do, it will look at that real data. It will build a statistical model based on what I explained, like the single columns, the correlation between the columns. It will build that model, and once that model is built, we can then ask it to create data from it, which we call sampling. And then you can say, I want 1,000 rows, 10,000 rows, 20 million rows, whatever. It will just take more time, of course, the more you ask. And then it generates the synthetic data on the left below. The algorithms we use, there are different flavors of algorithm we can use. Yes, please.
I'm sorry, how small the training
You want some water?
How small the training set is allowed to be? I mean,
Yeah, that's a very good question also. Actually, it can be pretty small. We had to learn that because in the beginning, some people also thought like terabytes or depends a bit on the algorithm we're using. But most of the time we will use statistical algorithms, and they are very compute friendly. You can actually run that on your laptop. And the size of training set is 10,000 rows is more than enough. Sometimes even works on a few thousand, but typically 10, 20,000 is more than enough. And what we also learned, we tried that, is if you make your training set bigger, at some point it just doesn't help anymore. Because the patterns that it can learn, if it can learn it from 20,000, just by adding more data is not going to help, because those patterns have been learned and you're just not adding new information to learn from. Of course, if you start removing rows, there comes the point where you're only left. For instance, if you would try on 1,000 rows, then you have to be careful, because then perhaps you might not learn the things you... A typical 10, 20,000, which is actually pretty small set. Of course, we take a random set. So if we have 10 million rows, we take 20,000, but randomly. Not the first 20,000, because those might be special, or so we do it randomly. And also, if you take more, the compute will go up. So you want to avoid, if you want to train from a terabyte, you could do that, but it would take, and then memory issues. And so a set size, typically 10, 20,000 is a good size. Flavors of algorithms we can use. We can use neural networks, typically GANs, that type of stuff. works very well on simple models, typically single table. If you have bigger models with referential integrity, parent-child relations, then these algorithms get very quickly into trouble. So that's typically something we would use for a single table. And then for anything bigger than single table, and actually also for single table, we use statistical algorithms, which are things like Coppola calculation. Well, Google it. So these are just statistical algorithms, which make sense because after all, we are building a statistical model. And that works on 30, 40. There is no limit really on how much you could do. And it is very compute friendly. So the need, for instance, in the beginning we thought we would have to use graphical cards and so on, but that's actually not the case. So I will give you the times with the examples I will give, but it's amazing how fast it actually is. So sometimes it's disappointing that it does what it does in so little time. A third thing that we are starting to look into, a third type of algorithm, is large language models. Some people are now looking into, could we perhaps use things like GPT-2 or 4, but you have to be careful with the size of these models, to do this type of calculation. But that's, it's still a bit in the state of research papers and some example codes. But that might be something, yeah, it's interesting. We have to look into it. But for the moment, no real clear view whether that is actually going to help us. But yeah, we are still looking into it. Now I will go through two examples. So the first example is the one I showed with the two screens with the start date and the end date. That was from bakery, so that's all I will show you. I will not explain that one. This one is the payment. That's the screens I showed in the beginning where we did the raise of hands to see whether it was real or fake. That's this project. So that was something that produced in this project. So what did we do? So this was a team, and they need test data, but they are not allowed to copy test data from production. Even if they mask, still not allowed. So that means that the only way they have to do testing is to either make their testing manual, which they did. So they made like one test case of 99 cents. It was always the same. Because yeah, it is a lot of work to do that, so you just make one and then you run it all the time. And then we start working with them, and what we did was we took a training set from production. It's payments, so these were messages. And 10,000, that's roughly perhaps, yeah, or 5,000. We take these from production. Our software runs in production, so we can just consume that training set there. We run it through our software, we build a model. Once the model is built, we can sample from it. And then we can sample a different number. So the training set could be 5,000, and then we can sample 10,000 payments. And the time it took was actually, I think it was actually 2 minutes. So that just takes 2 minutes to do the calculation to train the model and the sampling. That's all it takes. What we then did was we take the synthetic data and we put it back in the system where they want to do the testing. So in their case, that was an acceptance environment, so that's why people start to complain. So we put them there, so we replace, there is this queue where the payments are in that test environment, and we just put the synthetic ones there. The system doesn't know. The system doesn't know as long as we have done a good job. If the structure is okay, then the system will just happily process them. It doesn't know that they're fake, actually. So then the payment engine processes them, team can do the testing. Then we run into a little problem, because then once that payment engine has done its work, for instance, the balance on the account has to be changed, the accounting system has to be changed, so these are the back office systems. And then we had a little problem, because that back office system started complaining because the account numbers that we synthetically generated, it doesn't know them. So then what we did was, of course, two options. We could either then synthesize the back office systems, but that there are a lot of them. They are big systems, so we looked at it briefly and then decided that that was probably not something we wanted to try. And then eventually what we did was we took real accounts in that test environment. So they're actually not real, they're probably from a masking. And then we in the synthetic payments, we put those accounts. And that was the only matching we needed. So the whole back office matches the whole thing based on the account. So that's the only thing we needed to do. And then you get payments where there is this real account number. Well, real, it comes from a test environment, and all the rest is synthetic. And that team was one of the first teams we worked with, and that's more than 2 years ago, and now we are still working with them. So when they do new releases, so it's nice to see that for them it's not just a one-off, but that they now really try to use that in the releases that they deliver. Yes, please.
If they do a new release, they go to production, then they generate new specific data, and then they test it? Or
You're aiming at what if the data model changes, or?
you've created this set, right?
Yeah.
And you trained it with production data. Now you have a new release.
Do you have to
Then
redo?
you add a new field, but then you can't get that from production, right? So
Yeah.
how do you...
So the question is, once you're in a release cycle and perhaps your data model changes, which in their case at some point it did, do you then have to redo the whole thing, or how does it work? I hope that that is more or less your question. So indeed, if nothing changes, if the data model stays the same and there is no reason to believe that the training set is no longer valid, like something massively changed in the type of payments we have, then we can actually just use the same model and just resample from it. Or they could just use the sample they already have. But of course, if the data model changes, in that case, we have to redo the whole thing. Now, it only takes 2 minutes, so we just can't afford to do it.
Take the source in production, or you take then the source in...
Yeah, I think your question goes also in direction of what if this is a new development and I don't have that data in production to train from?
What is first?
Yeah. And so yeah, the question is, what if I'm building a totally new software and I cannot take a training set from production because, I mean, I'm still building it, so it's not there. We had already one project there. It's called, so that one is called Bakeries, so that's also reporting to the ECB. And actually what happened was we have the existing reporting, which is called Anacridy, so that's the same thing but for businesses. And then the regulator comes with a solution for retail, so for the, well, normal people like you and me. And then, of course, that's a new program, a new project. And indeed, we cannot take that data from production because it's not there yet. There are several solutions, but the solution that we applied in that case was that the data model from the existing solution was relatively similar to the new one that they were building, because after all, it was same type of reporting, but instead of companies, private persons. And what we did was we took the existing model and we converted that with a script to the new one. And then we trained from that. Now I must say that writing such a script can be very difficult, so it might not always be a solution, because you don't want to spend 3 months writing that script. So in that case, that is one solution. Another solution is we also have a generator that can just generate synthetic data out of nothing. But that's not that good because it's more rule-based. Because then you can say I have a numeric and I give you the minimum and the maximum. But so far what we have applied is that we try to take a model that exists and we convert it to the one we want to train from. Yes, please.
So what exactly, so how do you go from the statistics to having actual test data, in the sense that so you want to have anonymous data, right? So if you see that in 10% of the transactions, if someone named John Smith is doing a transaction, that transaction is always 10 euros, then in your test data you don't want to see exactly John Smith with
Yeah, exactly, yeah.
So how do you go from generating then? Do you want a different name with a different number, but still 10% of the transactions? And
so the question is actually, what do you do with PII, like name, phone number, address? Is there not a risk that by sampling they will just appear and they will just be in the data that you create? Indeed, we don't want that. So we have two solutions for it. One solution is that we use fakers, which are typical Panda Python fakers or customized fakers. So that means that if I have a name and I know it's a Belgian locality name, there are packages that can just generate you fake names from that locality. I mean, not Indian names all of a sudden, but just from that region. A second solution, which we're trying to apply more and more now, is that we learn that private information and then we generate it. For instance, phone number. A phone number has a structure. You can learn that, okay, these are real phone numbers from the region in Belgium, for instance, Ghent. And then the algorithm learns that, and then it will generate phone numbers from Ghent region, but they're not real. So that's the second solution. And more we want to do that one. Because if you want to use a faker, you still have to tell the tool which faker to use. And we want to make this as automated as possible. But indeed, if you would just randomly pull names, then the real name at some point will come out. It might still not be a problem, but risk people won't agree to that, so you can't do it. But it's still not a problem in a sense that that name will not have, all the other information on the row will not be from that person, of course. But yeah, still, it's a bad idea. You don't want to do this. So either we use fakers or we learn and we produce synthetic phone numbers or names. That's not something we already do, but you can also imagine that you learn the names, tokenize them, and you generate them. But indeed, special attention has to be paid to these personal fields, like email, phone number. These things have a structure, so you can learn them. Now, there was a question, and I forgot a bit who asked, I think it was there, about outliers. I think it was your question. How do you handle outliers? Is that not a problem? So the thing is, if we use these statistical methods, then, so on the left, so the black, the Gaussian distribution that you see is our model. And normally, the sampler will statistically cover all of that model. So it will hit a bit everywhere. So if you have a salary, for instance, it will generate small salary, big salary. Of course, the salary in the middle that are the most frequent ones, they will come out the most, of course. So it will respect this distribution, but still it will be a bit, random. Which could be okay, but that means that if for payments you want a bit like everything, then if you only generate 2 payments, then you might get unlucky, and they are both big amounts. So then probably you do 10,000, and then you know, okay, 10,000, I'll probably have a bit of everything. One thing we can do is what we call conditional sampling, and then we tell the software to only hit the green area, to say, only sample in that part of the model. For instance, only sample salary between 5,000 and 10,000. And that's nice because then I can do less test cases, but I can do the ones that I need. And I don't have to run 10,000 payments just to make sure that I have small ones and big ones. And something, and that's why, so in that way you could get your outliers. Now, the algorithm has become very good at detecting outliers, so even on the left, the statistical one will get the outliers, in most cases. If you really want to make sure, you could do this, the conditional one. You could say, make sure you have a salary more than 100,000. And if you really want to make sure, you can also say, generate a salary that didn't exist. So if it doesn't exist, then it's not in the model. So that means we can even generate stuff that wasn't in the model, meaning it didn't exist in production. So that we call that out-of-range sampling. And the advantage of using these techniques is that In the case of that payment project, what we then did was to say, okay, instead of 10,000 payments, we'll only do 20, but we'll make sure you have small amounts, big amounts, and then what we call memo payments. So that's a payment that should only be executed, say, tomorrow, and then payments that get executed today. So you have 4 combinations, and we just do 5 of each. So 5 small ones executed today, 5 big ones executed tomorrow, and so on. And the advantage is that then you only have 20 payments to test, and they are exactly the ones that you wanted to test. The other solution is you generate 10,000 payments, and you'll probably get all of this, but it's 10,000 payments, so it's just less convenient. Yeah, the advantages, I don't think I have to go too much into this. Once you set it up, it's very fast. Of course, there is the setup, and that's still something we have to get faster at, but once you have the model, the sampling is really just a matter of minutes. Privacy is very good. Of course, you have to pay attention to using fakers for names and so on. And the matter of incompleteness can be solved by forcing conditional sampling out of range, so you fill the gaps of things that you wouldn't get from production. Second example, this is a project, and we're actually doing now several of these projects, where we try to use this technology for testing APIs with a mocking software. So the mocking software is WireMock, so that's just an open source mocking software. And what is the purpose? So normally if you want to test an API, you'll be hitting the endpoint of the real API, and you send requests to it, you get back responses, and you test the API. So that's a more of a connected way of testing. Now, sometimes it's just more convenient that you can do this testing with a mock, so that you don't have to connect to the real API. For instance, if that API is not always available in your test environment. So the mock is more of a local testing. That means you hit the endpoint of the mock, you still send your request, and you still get response. But of course, nothing's really happening. What the mock just does is it takes your request and it sends back whatever response you told it that it should send back based on that request. So it needs a certain mapping table. So you have to tell the mock, if I send you this, then please, you have to send me this back. And that's all nice, so I want to do 100 test cases, so I have to tell the mock 100 request response pairs. Seems nice, till you realize that that is one, just one. So this is one we did for an API where you send the customer ID, that's that very long thing at the top, we call that a UID. We send that to a customer system, and then it tells me the response is on the right. So it comes back with the information of the customer. Customer has so many physical addresses, he has a phone number, so it has also virtual addresses, email. But that is just one. So if you want to do this 100 times, you would have to in some way type this up, or I don't know how you would do it, and then give that to the mock. So that puts a bit of a limitation on the use of such a mock. But what we can do, we can generate this. So what we do is we need a training set. What is the training set? We take it from the logging. So we use Merak, and you can have logging. So we have logging with request response pairs. We take real set, few thousand, probably more than enough. We take that, and then our algorithm will learn what they look like, and then build a model, always the same thing, and then from that, it can then we can then generate these requests, and then give that to the mock. So that's one. That's one way. So and the nice thing here is that we have a team doing the mock, and my team is doing the synthetic data, and we're actually kind of combining solutions to come to a better solution, because the mock in itself without synthetic data still requires quite a lot of work, because you have to tell the mock what to do, and if you then combine that with synthetic data, you actually just get a better solution. And again, I don't have to explain this, it's faster and so on and so I think we're more or less at the end, so you can try it yourself. That's the good news here. Well, perhaps we might still have some time for questions, but we are using a premium version. Of course, we have to pay for that. We have a license, but there is a pretty decent open source for that. So, so this is the link, or you can scan the QR code. This open source exists on GitHub. It has very good documentation. It has most of the features of the version that we use. The big limitation is that you cannot do big models. So let's say up to 5 tables, you might be able to do it. But if you want to do something bigger, then probably won't work. But you could start, and anyway, I think if you want to try this, you should start with 1 table and first learn how to do that one, and then you can go to 2, 3 tables. But you can actually try this out yourself. The only limitation is that you cannot use this version, at a product scale, let's say. But anyway, you wouldn't be able to because it can only do 5 tables. So yeah, that's I think what I thought was interesting to give you at the end of the session. And I think, if I'm right, we still have 5 minutes. Could that be the case? I think we still have 4 or 5 minutes. So if there's still a question, or even 2, I think we can take.
Yeah, I'm curious about mocking, because a mock is kind of unique because there is no production data yet. Just imagine there is like a change in the API, you have new fields, new objects in there, and there's like no history where you can learn from and then instantly generate new test data. How do you handle that?
Yeah, so this is a similar question to what you asked, is what do we do if this is a new API we want to test? And so we don't have logging yet, but yeah, because it doesn't exist. And then we are actually in the same situation as with that project, where we converted. We haven't been in that case yet, but I'm sure we will get there. And then again, we'll have to see how to do that. So either we will be able then to, so imagine that in these request response, typically JSON format, if it was just one little field added, then I guess with a script, we could just script it in. We could just take the old one and then with a script add that extra field or something. But you see that it depends, because if you're really massively changing the JSON files, then at some point, yeah, it is more work doing that at some point than what you wanted to avoid. But I think the strategy would still be the same. You would either take the previous one, and if it's a small change, just add these fields in there. Or you have to put dummy fields, so yeah, but yeah, good question. In many cases, of course, people want to do testing for APIs they already have in production. So in that case, it can work. For new API, yeah, that's a bit of a point we have to see. We also have this generator where we can generate data, but more rule-based, but that's not so good. It's so yeah, once we get there, I'm sure somebody will get with that case to us in the next months, and then we'll have to see. I think we can take one more question, if I'm correct. 2 minutes left. Sorry, yeah.
How do you guard the dependencies between systems? Because you get your data from one generated system, whereas, let's say, a UID or a party ID or whatever, you need that to get from another system other data. So how do you guard that data with that UID is in the other system?
Yeah. Yeah, so that's a bit, the example with the payment system was exactly what we did there. So you had the payment engine and then the back office. And we then have to see what is the connection. Typically the connection is not 50 fields, it's like 1 key or an account number or something. And then we generate one of them, and then we put the generated numbers on the other one. So then we cannot generate them in silo, because then they will have different values. So only one gets generated, and then those values we have to put it on the other one. But typically these models are very typically only connected on one key field. Perhaps not always the case, but in many cases it's just one field, like an account number or something. So yeah, we have to apply a little trick there, because the model, if you just let the model do, it will generate at the both ends different series of numbers, and they will not match. So that might be a feature in the tool, because we developed this tool together with Itasibo. That might be a feature we can ask them to implement. For now, it's a little script we write. Yeah, it's a good question. I think we ran out of time, or do we still have time? If there's one more question, perhaps we can take a quick one, or else we're done.
The last question. It wasn't possible. It wasn't allowed to use masking or scrambling of production data, because you can still run data analytics on it and extract information, sensitive information out of it. But your model is actually extracting statistical characteristics and relationships out of the production data and transfers it to the big data, where it still exists and is still vulnerable to the same attack. Because, for example, you can just like analyze from that generated data the average income per neighborhood, because it's still there. It's
Yeah. So
model
that's you ask very good questions. So the question is, what about your model? So the real data you don't want to share, you can share the synthetic data. We even have 2 projects where we share synthetic data with the outside party, but we will never share the models. Because of that, it's a small risk, but still it is a risk. If somebody has our model, he could sample like a lot and then learn things. It wouldn't be an identity attack at that point, but it would be something we call an attribution attack. So for instance, that person could learn, imagine that I had a database with very rich customers, meaning their salary all I, that's in a model. You sample, you see all I data, yeah, you know, these are rich people. So that's what they call an attribution attack. So that's why, and you could even have it in synthetic data actually. So, but we have metrics to see if that is a risk. But yeah, basically we're still having that discussion, but we don't share the models. So if we want to give data to an external party, we give them the synthetic data, but not the model. Okay, I think we're probably done. Thanks for listening.